given y equals to x squared minus 6x plus 5, it is in standard form, we're going to find the following parts of a parabola. Okay, first, we're going to change or transform our standard form of quadratic function into vertex form. So we're going to isolate 5 and we are going to find the third term to make this a perfect square trinomial. In that case, that is positive 9. So we will also subtract 9 to the other side to make it even. 9 minus 9 is 0, so it will still go back to its original value. Okay, so next we'll simplify 5 minus 9 is negative 4. Then we'll express x squared minus 6x plus 9 into exponential form, and this will be our vertex form. So this vertex form will be very useful in finding the parts of a parabola. So this is our vertex form. Y is equal to a times quantity x minus h squared plus k. So we just transform this from here. Okay, so let us start finding the vertex. The vertex is represented by hk. So our h is 3, our k is negative 4, and we already have our vertex. So we can find that vertex in our parabola here. That is the turning point of our parabola. Okay, so how about the axis of symmetry? It is represented by x is equal to h. Since our h here is 3, and we already have our axis of symmetry, that is x is equal to 3. Okay, so where can we find that axis of symmetry? So this axis here divides our parabola in exactly half. This axis is what we call the axis of symmetry. Okay, how about the domain? So the domain is the set of all possible values of x. Do you think that all values of x will be covered by this parabola? Yes, because as you notice, the position of the parabola, it opens, it spreads going to the left and going to the right, because this parabola continues to go on forever, so it keeps on expanding. It means all positive and negative values of x will be covered. Therefore, our answer for the domain is all real numbers, or this simply a capital letter R represents the real numbers. Or we can also write our answer in negative infinity to positive infinity. It means all numbers from left to right. Okay, how about the range? If x tells us from left to right, the range tells us from upward downward. Okay, so the values of y that corresponds to x. So in here, you notice that our parabola from positive infinity going down to 0, negative 1, negative 3, negative 4, it didn't proceed to negative 5. But it pivoted here in our vertex and it goes up again. So it means not all x's are covered. Okay, so it started from negative 4 all the way going up. So our range is negative 4 to positive infinity. Okay, so that is our range. How about the intercepts? When we say x-intercept, the value of our y is 0. When we say y-intercepts, our x is 0. Okay, using any of these equations, so I prefer to use the standard form, we will just substitute y into 0. Then we're going to factor x squared minus 6x plus 5, and that is quantity x minus 1 times quantity x minus 5. Equate each side into 0. So to find the value of x, add both sides by 1, and x is equal to 1. On the other side, add both sides by 5, so x is equal to positive 5. Therefore, our x-intercept is 1 and 5. How about the y-intercept? So let x is equal to 0. So simplify them. So it becomes 0 minus 0 plus 5, and finally y is equal to 5. So that is our y-intercept. Our y-intercept is positive 5. How about the opening of the parabola? If we are looking at the graph, it's so easy to tell that the parabola opens upward. But if the graph is not there, just go to the value of a. What is the value of a here? It is positive 1. Since it is positive, the parabola opens upward. Okay, for given number 2, y is equal to negative x squared minus 4x plus 5. It is in standard form, and we're going to find the following parts of a parabola. Okay, so we're going to set this first into vertex form. Then we're going to isolate this third term, and we will make our quadratic term a positive. So we can factor this by factoring the negative 1. Anyway, if we're going to distribute this here, it will just go back to its original given. So we're going to find another third term that makes this a perfect square trinomial. So 4 divided by 2 is 2, and 2 times 2 is 4. So that is how we find the third term to make a trinomial perfect square. So we add 4 here. We will subtract 4 on the other side because we want to maintain the value. Now, since this positive 4 is being multiplied to negative 1, so this negative 4 also must be multiplied to negative 1 as well. Okay, so we'll just simplify. Negative 4 times negative 1 is positive 4. Then write down. Then 5 plus 4 is 9. Then we just express this into exponential form, x squared plus 4x plus 4 into quantity x plus 2 squared. And this will be our vertex form. So this will help us to find the parts of the parabola easily. Okay, now to find the vertex hk, so our h here is negative 2 and our k is 9. Wait, sir, we only see positive 2 here. It's not negative 2. Actually, in the vertex form, it should be x minus h, but in here it is x plus 2. So we will rewrite this into x minus negative 2. So the real value here of 2 is not actually positive 2, but it is negative 2. Anyway, negative times negative is positive. It will still go back to its original given. So the real value here of 2 is negative 2. Then our k is positive 9. Okay, so how about the axis of symmetry? So x is equal to h. So our h is negative 2, and this will be our axis of symmetry. Now to find the domain. So most of the time in a parabola, the domain is all real numbers are from negative infinity going to positive infinity. As you notice, our parabola, even though it opens downward, it continues to spread as the parabola goes on forever, going down. At the same time, it spreads going to the right and going to the left. So all positive and negative values or set of values of x will be covered by this parabola. How about the range? Notice that it goes up 1, 2, 3, 4, 5, 6, 7, 8, 9, but it didn't pursue to 10. It goes back. It pivoted from the vertex. So it means not all y will be covered. So it is from negative infinity going to positive 9 only. So when it comes to range, it is the only covered. Okay, so how about the intercepts? Again, x-intercepts, it means y is 0. For y-intercept, x is 0. Okay, so we'll use the standard form of a quadratic function. Then we'll just set y is equal to 0. Then simplify. So we want this quadratic term to be in positive. We want to express this in positive so that it will be easier to solve. Okay, so this one is 0, then this one negative times negative is positive, negative times negative is positive, positive times negative is negative. So finally our quadratic term is now positive, and we can simply factor this one into quantity x minus 1 times quantity x plus 5. Then equate each binomial into 0. So x minus 1, so add both sides by 1 so that x is left and the value is 1. So on the other side, minus 5 to both sides, so x is equal to negative 5. So our x-intercept here is 1 and negative 5. To find the y-intercept, so set x is equal to 0, then simplify. So y is equal to positive 5. That's the y-intercept. Now for the opening of a parabola, by looking at the graph, we can easily say that it opens downward. Or if graph is not given, so just go to the value of a. What is the value of a? In this case, it is negative 1. Since it is negative, the parabola opens downward.